All right, well, welcome to our quarterly webinar. We call this webinar the themes of the new economy, and we do one of these every quarter. My name is Sean Morgan. I'm the manager of investment marketing. Let me explain to you why we do these webinars and what we hope to accomplish. So we believe that the power of global capital markets is enormous. Financial markets are extremely effective tools that can activate dormant capital and put it to good use. So we've seen tremendous innovations that have addressed some of our most pressing needs be enabled simply by businesses having access to capital from private investors. However, and there is a however here, the financial markets are only as efficient as we make them. So we can use them as they were intended to be used to create value for investors, businesses, and society, or we can misuse them. So we can passively engage with them and have no intentionality behind directing our capital, or we can see the financial markets as a game that we can manipulate and make money without even creating value. So we find it extremely important that within a society that relies heavily on private enterprise, that capital from private investors, that's me and you, is allocated to its highest and best use. So how do we do this? We start by identifying some of the most pervasive trends in the economy that are helping shape the future of businesses. So we call these trends secular themes as opposed to cyclical themes that tend to be more reliant on business cycles. To give you some examples of these, think of trends like artificial intelligence or cybersecurity, energy efficiency, technology infrastructure, or healthy foods. Now, we look at the broad secular themes and we ask, which themes do we believe are addressing important human needs? We call these themes of human flourishing. So on a quarterly basis, we do a deep dive into one of these themes on a webinar because we think it's important for advisors and investors to be intentional with how they're allocating their capital. So this quarter, we have a big one. I'm looking actually at an early release of the morbidity and mortality report for 2020. This is just released yesterday on March 31st. It usually takes about 11 months for this data to come in, but they expedited the processes this year to get us some provisional data just with COVID. So here's some interesting numbers from this report. In the US, the age-adjusted death rate increased, so year over year from 2019 to 2020, by 15.9%, going from 715 to 829 deaths per 100,000 people. Now, the third leading cause of death in the US last year wasn't even on our radar in January of last year. It was COVID-19. It killed about 345,000 people in the US last year. Now, the leading cause of death last year in the US was not a surprise. It was heart disease. Heart disease killed 690,000 people last year. The second leading cause of death was, you guessed it, it was cancer. Cancer killed about 598,000 people last year. And unlike COVID, we've come to expect this every year. So here are the projections for this year. We're expecting close to 2 million new cancer cases in the US this year. And we're expecting about 608,000 deaths from cancer this year. Now, I would imagine that everyone on this call has either been directly impacted by cancer or have someone very close to you impacted by cancer or has even died from cancer. And if you've walked through cancer treatment with somebody, you know how challenging it is. And if you're like me, I remember thinking, it just shouldn't be this way. Like, we should be further along in cancer treatment than what we were. So it's extremely encouraging whenever I get the chance to sit with people and have them explain what the future of cancer treatment might look like. So today, we have that person. I have with me Brian Chow. He's one of our research analysts here at Eventide. Let me give you a little bit of his bio. And Brian, you can go ahead and turn on your camera for us. So Dr. Chow, Brian here, has a PhD in neuroscience from Harvard, where he studied the biological mechanisms underlying the blood-brain barrier with the potential to enhance drug delivery to the brain to treat neurological disorders. That's what he studied at Harvard. He's published in a couple of medical journals and scientific journals. We're pleased to have him on the team doing research for us specifically around biotechnology. So Brian, thank you for joining us today.
Thank you so much for having me. It's a pleasure to be here.
So I want to start out, and I'm going to stop sharing my screen so they can just see us interacting here. We're going to take a step back. We're going to eventually get to walking through each of the common cancer treatments so you can explain those, but just take a step back with us and help us understand some basic biology so that we can understand cancer. Can you explain to us, maybe starting out at the most simple level, like explaining cells, like what are cells and what do they do?
Sure, yeah. So cells are the building blocks of our body. They give the function to our body. So we have various types of cells, from hair cells to brain cells to heart cells. And collectively, they work together so that we could live, thrive, and function in life.
Gotcha. So now our bodies, they're just made completely up of cells. Are we talking like hundreds of cells here or like billions, trillions?
Yeah, so we have a lot of cells. The estimate is that perhaps we have about 30 to 50 trillion cells in our bodies.
So, and we start out as just like one cell, and then that cell divides. And as we become more complex, like it divides, and these cells maybe have new functions. So the cells that make up our heart are heart cells, and they have a particular function of what they do. So
Yeah,
what is it that tells those cells? How do cells know what to do?
right. So as you mentioned, we all start off as one cell in development, and that one cell divides to two cells, then four cells, then eight cells, and etc. And during those divisions, those cells start to gain specialization. And the way they gain those specializations is that each cell all have a DNA in their cell. It's the master blueprint that gives and instructs the cells how to function and behave in our body.
And so as the cells divide, they're each embedded with this blueprint that is DNA, and it's telling them essentially what their role is and what to do.
Absolutely. Yep.
All right. So tell us then what cancer is.
Yeah. So cancer is when our cells go rogue and don't regulate the ways that a normal cell should behave in our body. So normally our cells are governed by rules and regulation, how fast they should divide, how big they should get. However, in cancer, the DNA becomes damaged. We call this mutation. And this mutation alters the way a cell should behave. So a cell that misbehaves becomes cancer. They go rogue and they start to grow uncontrollably and start to divide and divide. And we call this a mass.
So the rogue cell that is cancer, it starts out just as one cell that has just a mutated DNA. It has the wrong code telling it to do the wrong thing. And from that one cell, it divides and creates other cells that also then have this messed up DNA in it that is telling it to do the wrong thing. Essentially just divide uncontrollably and just keep dividing. And that's why you see like just like a mass start forming at a different part of the body.
Absolutely. It's kind of reminiscent to the game telephone, where one person will relay a message and the receiver may have misheard that message, maybe 95% of the message correctly. And then that person tells another person what they heard the message was. So eventually you get these accumulation of just misinterpretation. So by the very end, the last person will totally butcher what the original message was. So you could think of that as the DNA mutation accumulation. One cell has an accumulated mutation, and that continues to accumulate mutation over and over as the cell divides. And so by the end, the cell has just a misshapen DNA and eventually grows uncontrollably and becomes this mass.
So are there particular cells that are more prone to becoming cancerous than others, like different ones in different parts of the body?
Yeah, so usually fast dividing cells are prone to cancer, which makes sense because, so for example, skin cells, normally they're constantly turning over in our body because they protect us from the environment. So there's a fast turnover for them normally. And these skin cells also, because they face the harsh environment, they get damaged as well. So we need the constant normal turnover of healthy skin cells. However, skin cells, because that they have this intrinsic fast turnover, they are prone to cancer.
So yeah, I guess that makes sense. Like there's just more room for error if they're turning over quicker. Then there's just more chance that they would become mutated in
Yeah.
that turnover as they're making more cells. So what historically the main identification of cancer has just been location, right? Like location on the body. So if there's a mass on your lung, it's lung cancer, and that's as far as the diagnosis goes. Or if it's on your skin, or say that's skin cancer, and we have different types of labels for that. So describe to me now. Let's get into how we've treated cancer in the past. And I'm going to share my screen because I want everybody to see what path we're going to take here in describing the different treatments here. All right, so these I kind of laid them out like as far as timeline with how I know that they came to be. I might be misinterpreting like when each one of these were popular, but let's start out with maybe the most basic treatment for cancer, surgery. So tell us kind of what the surgical therapy for cancer is, and maybe some of its benefits and limitations.
Sure. Yeah. So surgery in the old days was the mainstay. It's still the mainstay today. So surgery, as it sounds, is the removal of the mass from the body. It's invasive, but it's a mainstay treatment because you're removing the source of the malignant cells.
So with surgery, tell me it's localized. So like if you have a mass on your lung, obviously like you just want to get rid of the mass. However, some of the unintended consequences are number one, you're removing something from the body, and so you might remove things that you don't want to remove. But number two, that it might not be localized, the cancer. So what do we call it whenever cancer has spread?
Yeah. So cancer, as you mentioned, starts as a mass, a tumor, but the malignancy of cancer is they like to continue to grow and eventually spread throughout the body, and we call that metastasis.
Gotcha. So if cancer is metastasized, then surgery might not effectively get all of the cancer out.
Absolutely. Yeah. So surgery, as you mentioned, it's a very localized treatment. We try to remove as much of the mass as possible, but of course, we can't be precise in removing the cells that may have migrated and metastasized to other parts of the body. And if we don't remove those cancer cells that migrate to the other parts of the body, then they could see to the other areas in our body and start to grow their own mass.
Because each cancer cell is capable of dividing, and once again, the telephone game occurs where all these rogue cells are kind of forming another mass in another part of the body.
Absolutely. Yep. So, for example, you mentioned lung cancer. Those lung cancer, we could try our best to remove as much of the mass as possible, but then those lung cancer cells can migrate to other organs in our body, and they could form their own mass colonies, if you will.
So further along, and then if anybody's gone through cancer treatment or walked with somebody through cancer treatment, they're familiar at least with these first three on this list. So surgery, like, hey, let's remove it. And then radiation is another common therapy that we experience. Explain to us what radiation is.
Yeah, so similar to surgery, radiation is still a quite a mainstay in the treatment of cancer. So radiation is using high energy beams to try to damage the cancer cells. So by blasting the cancer cell with high energy, we're trying to hurt their DNA. And by hurting the DNA, these cancer cells will die. However, radiation, similar to surgery, is still a localized treatment. And even though it is a localized treatment, we are still going to miss the other cells that could have metastasized to other parts of the body.
So I'm picturing radiation, and this might be a basic question that everybody on the call can visualize, but I can't visualize a radiation machine. Is it a machine that just kind of points at like a certain part of your body, or are you under like an MRI that your whole body's under? How does radiation, what does that look like?
Yeah, so they're both, as you described. There's a whole body radiation where patient could be on the platform, and then there's a local beam that's directed towards the cancer. That's absolutely a form of radiation that's rarely used.
So what are some of the common side effects of radiation?
Yeah, so as I mentioned, radiation does try to target the cancer cells by hurting their DNA. However, it's not a precise treatment. While in the process of trying to hurt the cancer cells, we also hurt our normal cells that are nearby that have also experienced the high energy rays. And by hurting our normal cells, we are going to effectively hurt them. So usually when a patient undergoes radiation, they experience certain side effects, such as fatigue, some skin irritation because we are applying radiation onto the surface. Hair loss is another one.
Well, why hair loss? Why does that happen with radiation?
Right, yeah, so because we're applying a energy beam to the surface of our body, and hopefully it penetrates and hits the cancer, the skin and the hair are gonna inadvertently going to get affected by the rays as well. And because they're gonna get affected by the rays, we're gonna see irritation of the skin and then hair loss of the body as well.
So would you ever use radiation in conjunction with surgery?
It's used readily all the time. So you could, for example, sometimes say a tumor is too big alone for surgery. So sometimes doctors will use radiations to try to shrink the tumor and then remove it.
Ah, okay. So let's move on to chemotherapy here. Explain to me what chemotherapy is.
Yeah, so chemotherapy is using chemicals to try to hurt the cancer cells. And unlike radiation and surgery, chemotherapy is a systemic therapy, meaning that we can either ingest it orally or deliver it via intravenously. And the chemicals should go throughout our body and hopefully hit the cancer cells that may have migrated outside the original tumor and hopefully hurt them in the process.
So how does chemotherapy, like if you're taking a pill, or I guess if you're injecting it, how does the chemical know what cells to attack?
Yeah, so the short answer is it doesn't. Well, what chemotherapy relies on is the fact that cancer cells are, as their biology is, they're fast dividing. And what chemotherapy leverages that biology is that hopefully by trying to attack the rapidly dividing cells, it will hurt those cells over normal cells that are slower in dividing. However, that distinction is blurred. So that's why you see a lot of side effects with chemotherapy, including fatigue, loss in red blood cells, loss in white blood cells, hair loss, some neuropathy sometimes.
So the main, I guess, the main thing that attracts the chemicals that are coming into your body from chemotherapy is just the fact that cells have fast dividing characteristics. And so
Exactly.
So this is just any type of cell that we have that has fast growing characteristics, with even like white blood cells, red blood cells.
So yep, and that's why when a patient undergoes chemotherapy, you usually see side effects of lower blood cell counts, and then that manifest into experiencing fatigue, maybe prone to infections.
And so it's essentially a poison. And
Essentially, it's a poison, and hopefully you're trying to direct that poisonous therapy towards the cancer cell over the normal cells.
interesting. Okay, so and you would use chemotherapy sometimes or oftentimes in conjunction with radiation and surgery?
Yeah, that's right. Chemotherapy is still a mainstay in cancer treatment.
And mainly because so surgery is localized, obviously, like you're removing just a mass from a particular area of the body. And then radiation also is localized to the part of the body where probably that mass was. And chemotherapy is just kind of a blanket, almost carpet bombing of the entire body, all the cells in the body. And it's hopefully killing all the cancer everywhere, but along the way, you're having to monitor how much chemical you're putting in your body, because it's going to kill good things too.
Exactly. Yeah. So as you mentioned, chemotherapy has an advantage over surgery and radiation is that it can spread throughout the body. So hopefully it could hunt down those rogue cells that may escape surgery and radiation, these local treatments. But the disadvantage is that by also exposing it systemically, we're also inadvertently hurting normal cells in the process.
All right, so I want to stop here for just a second before we move on to immunotherapy and precision oncology, because we're considering these newer treatments. But I think that the foundation for it that enables these new treatments is that we've discovered some new things about cancer now that we didn't before. So maybe explain to me some of the things that we know now that we didn't know as surgery, radiation, and chemotherapy were being developed. What do we know now about cancer?
Yeah, so over the past decade and 2 decades ago, we learned a lot about cancer and specifically what drives cancer. So we talked about how cancer starts with mutation. With the advent of DNA sequencing and also understanding of immunology, we have a better understanding of what drives cancer, what keeps cancer in check, and we could leverage those biology to try to develop new therapies. And you mentioned them, immunotherapy, and then after that, precision oncology.
So explain to me what immunotherapy is and kind of where we are in development of immunotherapy and how often it's used.
Yeah, so immunotherapy is the most exciting breakthrough that happened in cancer this past decade. So let me back up and just mention that normally we have an immune system, and that immune system keeps our body healthy. So we are used to our immune system fighting bacteria and viruses to keep our body healthy. In addition, our immune system also makes sure that our normal cells don't become cancer cells. They're really good at detecting that. So that's just a normal process. However, when a cancer cell starts to mutate, they become really good at escaping our immune system to a point that our immune system can't recognize them or have a hard time attacking them. What immunotherapy does, it's a medicine that tries to leverage the immune system to re-recognize and re-attack the immune system, or to re-attack the cancer, excuse me.
So this is you said a medicine. I'm thinking of a pill. Is it a pill or is it an injection?
Right now, the mainstay is it's an injection. We call this a biologic. What it does is it can help a certain type of immune cell called T cells recognize cancer cells and attack them. So it's leveraging our own immune system again to fight the cancer cell.
So, and is this a one pill that is universal, or is it designed specifically for each patient?
So this is a intravenous injection, which allows, which can be applicable to many patients. It doesn't have to be catered or tailored to one specific patient. You can apply this across multiple patients.
Gotcha. So there's no reason to, and does it apply to all cancers, or is it specific to a type of cancer?
Yeah, so one of the coolest thing about immunotherapy is that we've been finding a role for immunotherapy across broad types of tumors. So from skin cancer to lung cancer, immunotherapy has been revolutionizing the whole cancer field and the way we treat it.
So who and the nature of these calls, we just talked broadly about themes and technologies and things like that. And we don't ever get into company specifics or company names. But can you tell me the types of companies? Like, are these research and development companies? Are these manufacturers? Like, who is a part of this immunotherapy ecosystem?
Yeah, so it's essentially what you said. There are biotechs, there are big pharmaceutical companies, there are diagnostic companies that are trying to understand which patient could benefit from immunotherapy. So it's a whole ecosystem that are trying to develop cutting edge immunotherapy medicine.
All right, let's switch over to precision oncology. And this is really exciting too. And I know we speak a lot about it at Eventide. Explain to us what precision oncology is. And
Yeah,
some
so
of the other names too, because I know people call it a lot of different things.
right, as you mentioned, there are a lot of synonyms for precision oncology. So a few ones that are popular are precision medicine, targeted therapy, genetic precision therapy. What essentially they are saying the same thing is with the advent of DNA sequencing, we can start to figure out what are the mutated genes that drive cancer. And by figuring out which genes are mutated, we can develop therapies to specifically target those mutated genes, and hopefully that will stop the cancer.
All right, so walk me through this entire process of how we would use precision oncology. So there's an original diagnosis. You have cancer. We need to find out more about it. Is that the next stage of the process? And what I'm thinking that historically happens is you cut off a piece of the mass and send it off for a biopsy. I think that's how it used to happen. Is that still part of the precision oncology process?
Absolutely. So right now, we take a biopsy. So we take a needle, take a small sample of the mass, and then we can send it out to a lab where they do diagnostic workup to understand what type of genes are mutated, what the cancer has increased the mutation. And from that information, we can then identify which drugs have the best efficacy against that tumor.
Gotcha. And that's with precision oncology in particular, is like.
Exactly. Yep. So say we found that in this tumor, the gene that's mutated is called HER2. We have a bunch of HER2 drugs in the pipeline. We could then pick and choose which HER2 drugs could best help the patient in that scenario.
So the advantage here is, so traditionally with, I'm going to compare this to chemotherapy. So with chemotherapy, you put a chemical in your body and it's just designed to attack all the quickly dividing cells. And so cancer cells are targeted. However, it hits a lot of other unintended targets as well, which causes a lot of problems all over your body.
Yeah.
So with precision oncology, the medicine is designed just to hit that specific type of cancer that that person is diagnosed with. Is that correct?
Exactly. So we were trying to be precise and hopefully selecting a medicine that is tailored to the patient's mutation. So that way we don't have to use a broad blanket chemotherapy, which could have a bunch of side effects. In this case, we're specifically trying to target a specific mutation that the patient carries to stop their specific cancer.
So, and you said like HER2 is an example. So I'm thinking, so HER2 would be a description of a cancer as opposed to lung cancer. It would be more precise and say, this is specifically HER2.
Yeah, so when we talk about, say, lung cancer, a lot of things could drive lung cancer. A lot of genes that could be mutated could drive lung cancer. what precision oncology offers is we're trying to understand the specific mutation that manifests into that lung cancer. And HER2 is one good example of that. Right now, there are there are interest in the field to identify lung cancer that's driven by HER2. And then there's a lot of development in identifying a selective and targeted HER2 therapy to stop HER2 lung cancer.
It's super interesting. So what I'm thinking of in my mind, one of the biggest benefits is just the lack of side effects. So like this is going to drastically reduce side effects compared to chemotherapy, radiation, and surgery, really.
Right. So it definitely, relative to chemotherapy, targeted therapy offers not only better efficacy, but also better safety and tolerability. You might not have the same side effects as what chemotherapy has, such as I mentioned before, fatigue, hair loss, skin rash. However, each targeted therapy could have a different safety profile and tolerability profile, because as you can imagine, say we talk about HER2, HER2 could be expressed in normal cells, but given that HER2 is more likely to be mutated or overexpressed in tumor cells, hopefully we're attacking the tumors, preferably over normal cells that express HER2.
All right, so with immunotherapy and precision oncology, we've been mainly talking about them on a treatment basis. Has there been any exploration as far as using these for preventative care, specifically with immunotherapy? It seems like that might be a good candidate for preventative care too. Has that been explored?
So preventative care, just to clarify, is when we try to screen normal patients before they get cancer. So right now, we are not leveraging immunotherapy or target therapy for preventive care, as in we're not prophylactically taking a medicine to prevent cancer. What we are deploying is we're trying to use screening for certain cancer as a way for prevention of that cancer. For example, in colorectal cancer is the second leading cause of death in the United States, or cancer-related death in the United States. We are now we're now screening people, normal, healthy people, aged 45 and older, to see if they might have colorectal cancer. If we catch it in the early stage, then we can use surgery and prevent colorectal cancer from ever manifesting.
Interesting. Okay, so and I don't have that listed here as a theme, but like, are we making a lot of progress in cancer screening? Like, is that different now in 2021 as it was in 2010?
Absolutely. Yeah. So one of the most exciting field is actually in the cancer diagnostics and screening field. So one of the most exciting is trying to look for potential cancer signature in the blood. And so the idea is that, hey, let's just go get a blood draw and then see if we could identify signatures of cancer in the blood. And if we could detect that, then perhaps we could catch it early and help people prevent the cancer. We could intervene before cancer happens.
Which is the idea, because I showed two stats or two projections. One is for 2 million cases of cancer to happen in the first place. Like, we need to do something about that number. But we also need to do something about the 600,000 deaths that are going to occur. So if we can make progress in both of those areas, then I'd say that's good progress. Those are good themes to invest in.
Absolutely. Yep. So if we could catch cancer, then we could effectively reduce both those numbers. If we could have better therapies, then we could reduce the cancer-related mortality.
So do you eventually see us in a position, and maybe on some spectrum of timeline, where precision oncology and immunotherapy, because I'm seeing a big benefit of those would be the reduced side effects, and due to their more precise nature, where they're not attacking good things in your body. Do you see those eventually being able to maybe replace chemotherapy, radiation, and surgery? Or do you think for a while we're going to use them in conjunction with? How do you see that playing out over the long term?
Yeah, so what we see in the field is that both immunotherapy and precision oncology have been changing the standard of care for various cancer treatments. What we have been seeing is that um, we've been seeing that these type of newer agents try to displace chemotherapy. So we'll do a clinical trial and say, hey, chemotherapy used to be the standard of care, but it has all these side effects. Let's see if immunotherapy alone could offer the same benefits while reducing the side effects. For us to make that decision, we'll have to do a clinical trial where we compare immunotherapy versus where we compare chemotherapy versus immunotherapy and see if that hypothesis is true or not. If it is, then that's great. We could displace chemotherapy with these newer agents and have better outcomes for patients. But medicine is very empirically driven. So until we do these type of clinical trials, we will always have to rely on the standard of care first before we're trying to deploy these newer agents.
Gotcha.
But in terms of the cancer research, that's what it seems to be trending towards, that these newer agents are hopefully trying to displace chemotherapy.
Now, I believe for me, that's where I would see the biggest benefit is if we're able to rely less on chemotherapy. Rely less on chemotherapy. You just see so many people just getting just bombarded by all of the side effects of chemotherapy, and it's really painful to watch. And I imagine some people on the call have even experienced it themselves, where you just feel like your body is deteriorating as you're trying to fight the thing that is, killing you.
Absolutely. Yeah. The side effects of chemotherapy are very devastating. And I'm sure we've all seen or know of someone who have undergone chemotherapy treatment. And it's, as you mentioned, it's a poison to the body. Hopefully you're trying to kill the cancer cells, but at the same time, you are hurting your normal cells. So there are a lot of side effects from chemotherapy. And with the newer agents, such as immunotherapy or precision oncology, we can mitigate and displace those side effects with better agents that give better outcome and hopefully better tolerability as well.
That's so good. It's so exciting. I've even within my family, like we've walked through it here in the last year, and it's never encouraging whenever that first report comes back. It says, "Hey, you have cancer." There's just this unease within you, within your entire family, to just know that the road ahead is just going to be so tough and so rocky. And so for us, and as I started this call, I was talking about how important it is, especially in a society that relies so heavily on private enterprises to meet our essential human needs. We saw that throughout the pandemic too, where businesses in a lot of ways stepped up to the plate to provide for some of the things that we needed most. And so we're seeing that play out in medicine too. And it's no surprise that in a country where the private markets are so effective and so popular, that this is where a lot of innovation happens, is right here. And so these companies are focusing on these things that are going to impact so many people. And I think of the story of a friend of mine actually here in Dallas. He told me this story, and we've actually told it here at Eventide, that he inherited money from his grandmother whenever his grandmother died. And it was well known, and she knew what killed her. It was lung cancer. And her lung cancer came from her lifelong habit of smoking. Within this inheritance, he noticed it was stocks, and he looked at the account and see what individual stocks it held. The largest holding in there was actually the cigarette manufacturer that she smoked. Yeah, these were who she was a customer of. And I remember he was saying this, I believe he was in high school when he inherited this, or maybe a little bit younger. And he remembers being almost angry at this. He says, I'm actually going to be profiting off of this company that whose product actually killed my grandma. And to think of the opposite of that, to say that, man, we could invest and direct our capital towards companies that are actually healing and finding cures for the things that are killing people. It's just such a powerful thing to think about, of using this incredible tool of the capital markets to direct capital towards businesses that are creating value to society. Such a powerful message, Brian.
Yeah, absolutely. I completely agree. If we could deploy capital to companies that are trying to develop newer medicine that can hopefully help patients survive longer, have a better quality of life, I think that's a huge win for all stakeholders, patients, physicians, companies, investors. I think we all can rejoice if we see that.
That's right. So at Eventide, we call this investing that makes the world rejoice. I want to make a couple of announcements before we sign off here. We do have upcoming webinars. If you enjoyed this webinar, we actually do one of these once a quarter. Next quarter will be on housing and how we kind of invest in capital markets under this theme of affordable housing and providing housing for a lot of people. It's going to be a really interesting webinar that I hope a lot of people tune into. And let me give you some information on how to sign up for our CIO macro update, which is on Wednesday, April 21st. If you go to go.eventideinvestments.com/macro-registration, again, go.eventideinvestments.com/macro-registration. That's our CIO macro update. Finney Curvilla, our CIO, he gives his views on the economy, what's going on there. He uses 3 legs of the stool approach where he evaluates different areas of the market and gives his analysis. We also have a portfolio review where we review the progress of our portfolios over the previous quarter. So the portfolio view for Q1 is actually on Thursday, May 13th. You can register for it and sign up for future content that we have at go.eventideinvestments.com/partnership. Again, go.eventideinvestments.com/partnership. You can go to that URL and sign up for other communications that we have and other resources that we give out too. Well, thank you very much for joining this call. Brian, thanks for joining us. It was very insightful. I loved walking through this with you. I've learned a lot. I hope everybody on this call learned a lot. But thank you for your time, Brian.
Thank you so much for having me. This was really fun.
Good deal. All right. Well, everybody enjoy your afternoon. Thank you for joining. You may now sign off the call.